a little bit more. We're going to do a composite function. So let's define some functions. So if I say f of x is equal to x squared minus 1, and can you guys see that okay? I'll zoom in a little bit. And oops. It takes a second for the autofocus to focus in. There it goes. And then let's let g of x equal the square root of x. Alright, so now what their textbooks wants me to do is do f of g and g of f. So for part A they want us to do f o g, or f of g of x. Actually I did it backwards. They wanted you to do g of f first. So now what I'm going to do is, what is f of x? Well, f of x is something that we put an x there, squared minus 1. Okay? And that something that we're going to plug in is g of x. So we're going to say the square root of x. And so sometimes you'll see it written this way. You'll see it written as f of g of x. Sometimes you'll see it written that way. Okay? So now to complete this, if I say f o g of x, which is sometimes written as f of g of x, then what is the square root of x squared? Just x. So that's x minus 1. We're going to find the domain on that in a second. We'll come back to that. I'll leave a little room. Does anybody have any questions as to what Mr. Adams did? It's a little confusing. Let's do g of f and see what we get for that. So I'm going to slide down here a little bit, and I'm going to say let's find g o f and of x. Yes. Oh, it comes out very green on the screen, doesn't it? On my screen it looks nice. Okay, so let's highlight. Let's go over it again. If I say f of g of x, that should equal this stuff, which is the same as saying f of g of x. And so if that's the case, we take f of x and we just plug it in, and then our final answer was x minus 1. And I apologize for that, looking a little silly. And so now if I do this again and I say g of f of x, that would be, what is g of x? G of x is, well, let's write it like this. This would be g of f of x. Well, what's g of x? Well, g of x is the square root of something. Well, what is the something we're going to plug in? F of x. So what I've done is I've taken just this portion here, wherever there's an x, and I've plugged in f of x. Do you guys see what I've done? So now in the next step, if I were to say g of f of x, I would get g of, now what is f of x though? X squared minus 1, right? Do you guys see that? So on the next line, what do I write down? X squared minus 1. So my final composition is going to be, whoops, let's use purple. My final composition is going to be g of f of x is equal to the square root of x squared minus 1. Does that make sense? So now let's go back and look at the domain. So on this function, if I were to look at the domain of this thing, are there any restrictions? Is there a square root symbol? No. Is it a fraction? No. And then there's some other things with natural log and stuff like that that we could consider. But for this particular one, the domain goes from negative infinity to positive infinity, or all real numbers. And sometimes in math we call it all reals, all real numbers. Now let's come down to g of f. Is there a fraction? No. So we don't have to worry about 0 in the denominator, but there is a square root. What's the problem with square roots with regards to the domain? I can't take the square root of a negative number. So that means that x squared plus 1, or I'm sorry, minus 1, it has to be greater than or equal to 0. That's kind of complicated. Now, what we're supposed to do is solve for x, but because it's a quadratic equation, we have to factor it. This is a difference of squares. This is actually x plus 1 times x minus 1, and we're going to solve to figure out where the zeros occur. And then we go back and look to see what makes the inequality statement true. Well, if that's the case, then I'm looking at x equals negative 1 and x equals positive 1. And that just comes from saying x plus 1 equals 0 and x minus 1 equals 0, and then solving. So now what that looks like algebraically is we have a parabola that crosses at negative 1 and 1. And we're looking for the positive values, the positive y values, right? So that means we're looking at this value and that value, because we don't want any negative y values. So our domain then would have to be what? Our domain would have to be negative infinity, comma, negative 1. Can we include negative 1? Yeah, because it can equal 0. Union 1 comma infinity. Can we include 1? Yeah. Let me zoom out a little bit so you can see everything I've written down. Boy, that was a doozy, wasn't it? Any questions on that? Do you guys understand why we want positive values here? Because the square root has to be positive. We have to take the square root of positive, or I should say non-negative numbers, because you could take the square root of 0. So long as it's not in the denominator of a fraction.